Good morning, and welcome to the PCO-7114-22-2 product introduction webinar. My name is Stephen Krause, and I'm joined today by James Budai. Hello. And before we get started this morning, I want to talk a little bit about the functions of the webinar and what we're going to go through. And then we'll do a recorded video that will roll for you. And then we'll have a live Q&A session. So this whole webinar is being recorded so that participants or people who wanted to participate can view it later. If you're participating on the Zoom platform, you'll notice that there are a few functions that might be helpful. In the chat function on the left of the screen, the lower left of the screen, you can send us a quick message. You can raise your hand in the center of the toolbar down there. That lets us know that you need some attention, that there's something that's not working, and then you can send us a chat and let us know what's going on. And then finally, there's an ask a question on the right side of that toolbar. And those questions will be going into a pool of questions that we'll answer during the Q&A session. So kind of use the chat session for something that really needs to be addressed right away. For example, right now, if you could let us know that the audio and video are working properly, you should be able to see James and I on video for this introduction, and you should certainly be able to hear us as well. And so if you could just let us know that those are working, then we'll know that we can proceed with the rest of the webinar. And then finally, like I said, at the end, we'll do a live Q&A where we'll be answering questions through the Zoom platform. If you have questions that you would prefer to keep private, maybe they involve intellectual property or the conditions surrounding those questions are more complicated or more complex, then it's convenient to describe in the little Q&A box. Please feel free to email us at sales@directedenergy.com, and we'll be happy to get back to you with an answer on that regarding how the PCO-7122 will fit into your workflow. And at the end of the webinar or anytime, if you can let us know how the webinar went for you and how we can improve it and make it better, that's fantastic. We look forward to any kind of feedback that makes this a better use of your time. All right, so what are we going to cover today? We're going to talk, we're going to have an introductory video that is going to cover the product in an overview. We're going to talk about what's in the box when you order a PCO-7114-22-2, what do you get? We'll talk about some accessories and replacement parts that are available. Then James is going to go into a technical overview and kind of give you an under the hood kind of view of how the unit works and some of the ways to use it properly. How do you set it up? And then finally, we'll talk a little bit about some solutions to common problems. Then I'll come back on and we'll talk about price and availability. I always like to give a little brief overview of the Lab to Launch program. And then we'll, like I said, we'll go back to the Q&A session. And so without further ado, let's go ahead and get right into it.
The PCO-7114 is a series of laser diode driver modules that provides from 6 amps to 50 amps of pulsed current at frequencies over 1 megahertz. With configurations covering a wide range of operating conditions, this versatile module is ideal for extremely fast, high-current, pulsed laser applications, including ADAS, LiDAR, range finding, and research for both OEM designs and single-end use.
Hello, my name is James Budai. I'm a design engineer for Directed Energy. Today I will be discussing the PCO-7114-22-2. Product overview. This is a fixed pulse width laser diode driver. It's open frame, which just means it's a printed circuit board. It's designed for OEM applications, and this should enable you to focus on your core product and us to deliver a good, clean pulse for you. When you order a PCO-7114, what do you receive? You receive an operation manual, the unit itself, and a control cable. There are also a few optional accessories. You can get additional control cables. You can get an optional current monitor cable or a micro stripline cable. Here is a front and rear view of the board. There are actually two models available. One of them is a 22-2, which is 22 amp output with a 2 nanosecond pulse width, or a 50-4, which is a 50 amp output at 4 nanosecond pulse width. This module is designed to provide an extremely fast, high current pulse to a laser diode. The output current range is 6 amps to 22 amps. The rise time is 2 nanoseconds, plus or minus a nanosecond, and the pulse width is fixed at less than 2 nanoseconds. The output current is set by adjusting a high voltage input signal. 0 to 180 volts produces an output current of 0 to 22 amp. The input trigger is a 0 to 5 volt signal that must be able to drive a 50 ohm load. The current monitor, which requires the use of an optional current sense cable, will drive a 50 ohm impedance on an oscilloscope, and a 1 volt output on the current monitor cable equates to 20 amps output of our module. Here's a list of supported devices. I should also mention the micro stripline cable at the end can allow you to connect almost any diode package that you have. Here is a safe operating area graph. So we'll do a quick example. If you look along the x-axis, and let's say we want to drive 20 amps on our laser diode. So you find 20 amps on the x-axis and you go up until you hit the blue line. Then you go over to the left until you hit the y-axis, and you see that the maximum frequency is right around 300 kilohertz is the fastest you can operate at 20 amps. I have two graphs that are actually oscilloscope shots, one at the lowest current setting, which is 6 amps, and it shows a 1.66 nanosecond pulse width. And this is driving a shorted load, and we inverted the current monitor just so it's easier for you to see what the actual output current is. Here's the same output current at 22 amps. We have a slightly smaller pulse width. Let's go through setting up an instrument. So the white box here is what you'll receive. Opening it up, we have the control cable, the unit itself, and an optional current monitor cable. Opening up the box with the unit in, and let's hook the control cable up to J1. Here's another view of the same thing. The first thing we're going to do is we're going to hook the red and black wire up to the DC power supply. This is our housekeeping supply, the plus 24 volts. Here's our trigger input. We're connecting this to a Tektronix function generator, and this is connected to the orange and black wire. And finally, our high voltage is connected to blue and black to our high voltage power supply. There's three things shown on this graph. One, let's start on J1 on the right-hand side. There's a red arrow there. Notice the polarity of the blue wire. It's on the upper right-hand side of the printed circuit board. Next, there's an arrow on the optional current monitor cable. You see the red arrow is pointing to the green wire. That's towards the center of the printed circuit board. There's a resistor that's towards the edge of the printed circuit board. And finally, there's a short on the laser diode. We test with shorts here in the factory. If you have your laser diode available, you can solder your laser directly to it at this time. Here is our entire setup up and running. You can see that the bottom supply is our high voltage, 150 volts. The housekeeping supply is at 24 volts, and we have our function generator with the trigger on. And here is the same scope shot we showed earlier. This is a 22 amp pulse or 22 amp output, and we have a little less than 1.6 nanosecond pulse into our shorted load. Now, here's some solutions for some common problems. What if you have no light output from your laser? There's a few possibilities of what's going on. One, you need to make sure the polarity of your laser is correct. 2, make sure the polarities of J1 and J2 are correct. That's your IMON cable and your input, your control cable. 3, can your trigger source actually drive a 50 ohm load? You're not going to be able to drive this with digital logic directly because digital logic cannot drive a 50 ohm load. Are both the 24 volt and the high voltage sources on? And is your trigger signal on? Some other problems might be reduced output or ringing on the laser output. You need to make sure all your connections are solid. Second is make sure that your trigger frequency is at or below the frequencies shown on the safe operating area graph that we went over earlier. And third, you must assure that your connections on your laser diode are made as well as possible to reduce inductance and resistance. You need to keep those leads as short as possible and soldered as well as you could. Also, you can use the micro stripline cable, but the output on the laser connected to that is never going to be as good as a laser connected directly to the printed circuit board.
The PCO-7114 is a fast, flexible, affordable, air-cooled laser diode driver module that can jumpstart your design process and meet your OEM integration needs in manufacturing. Contact Directed Energy and find out how we can help you from lab to launch.
All right, thank you. We hope you got some good information out of that video. Like I said, I want to talk a little bit now about pricing and availability. We do have 7114-22-2s in stock, and they start at $94 a piece in evaluation quantities. Those are US prices. Obviously, there are conditions outside the United States that we don't have control over. So if you're outside the United States, the pricing that we publish here in the US might be a little bit different in your location. And like I said, they're in stock. Normally, they're a stock to 4-week product. I also like to talk about the Lab to Launch program. The PCO-7114 series is a great example of the Lab to Launch program. And what that is, we like to work very closely with customers as early as possible in a project and get to know the project and the customer's application so that we can provide the best possible solution as an OEM product. And oftentimes, a customer will start with an instrument level product because they generally have wider ranges of operation, and that gives them a lot of flexibility in the laboratory where they can do a lot of experimentation and try to come up with exactly what they need their product, their finished product to do, and then they tell us, okay, we know exactly what we want now, and this module needs to do this thing, needs to have these characteristics, and at that point, we can design a module for them that provides what they need in their final product. And then you can have it manufactured by us, where all of our manufacturing is done in ISO 9000 registered facilities. With the products are all RoHS. We can also add other certifications as required, and we can provide you a tested module that you can just put into your system and move on. You don't have to worry about designing a laser diode driver or having it manufactured or testing it or anything else. You can focus on what your main core competency is in terms of your product line and your customers, and let us do the work on the pulse laser diode driver side. And at this point, we'll like to open it up for questions. Please put your questions in the Q&A section of the Zoom software, and Marty will relay those to us, and we'll get started answering them. This may take a little bit of time, as it takes a little time for people to get things into the chat. So if there's silence, we're still here, but we're waiting for your questions.
How is the waveform at 3.5 amps? The question is.
Okay, so the question is, how is the waveform at 3.5 amps? Well, I believe we're spec'd can we go back to the technical slide? Probably not, huh? So we would have to, we could take a scope shot of that and send it to you.
We should be able to go back.
If we can open up the data sheet, we can show, we usually have a graph of the minimum output current and the maximum output current both. So we'll take additional questions while we're looking that up, but and look at the data sheet. Okay, can we go down to the second page, please? Okay, it looks like our output current is rated from 6 amps to 22 amps. So we can go ahead and show you what it looks like at 3.5 amps, although this unit is not rated for it. This is a perfect segue to the lab to launch, because if you have a customer that really requires operation at 3.5 amps, then we can customize this module to work down at those current levels.
With a rise time of 2 nanoseconds, what's limiting the max frequency? Could theoretically much higher.
The safe operating area is set, which sets your maximum frequency, is because of thermal issues on the board, or either the MOSFETs are getting hot, or the resistors are getting hot, or the amount of stored energy in the capacitors. That's what's there's a combination of things that is limiting the maximum frequency. But once again, if you need a higher frequency than we state on there, we can custom design a unit for you.
I have a question here. Could we add a bias current, i.e. 500 milliamps with a wide band inductance?
We don't typically add a bias current on these real fast modules, but it is possible. We can customize something like that.
But I think the question is, could they do it somehow? Could the customer do it?
We can work offline on that. Why don't you send in the question in an email, or Marty, if you can keep their information, we'll get back to them on that.
Okay.
We have a question here. Have you some indication about the environmental sustaining temp vibration?
We don't have any vibration data on it, but the temperature range is specified in the data sheet. Okay, and another thing I'd like to mention is we try to design everything using automotive and soft termination capacitors. So it should be okay to use in an environment that has some vibration, but we haven't quantified that.
Okay, thank you, everybody. We'll go ahead and I want to respect everybody's time, so we'll go ahead and close it off at this point. Thank you very much for joining us this morning. You can contact us at 970-493-1901 by phone, or by email at sales@directedenergy.com, or visit our website at directedenergy.com. Again, if there's anything we can do to make these webinars more valuable to you, or if something didn't work like you anticipated, please let us know that as well so that we can improve them in the future. Thanks again, and have a great day.